Now we shall start the topic called Indices and Surds. It is a part of algebra, right? Both indices and surds are related to powers. Okay. Say for example, a raised to the power 3, b raised to the power 5, c raised to the power x. Okay, so we are talking about indices and surds in which they involve the powers. There is some base and there is some power attached to it, right? Indices is the full form of the word index. Index means integer power. We'll take all of them one by one. So when the power is integer, we call them index. And when the power is fraction, we call the expressions as surds. So this is fraction power. Okay. Now let's take one by one what means what. Okay. Now first of all, we need to understand that when I say a cube or b to the power 5 or 4 raised to the power 10 or 3 raised to the power 100. Now here this a, b, 4 and 3, they are called base. So in all these cases base is a, b, 4 and 3, right? And their power, which is also called in this case index, right, is in the first, for a the power was 3, right? For b the power is 5, alright? This 10 is the power of 4 and this 100 is the power of 3. Okay, so this is what we mean by just the terms indices or index. Okay, now similarly, what is the meaning of fraction power? Let's see. When we say square root of a, now this is something that all of you are aware about. What is the meaning of square root of a? It means a to the power 1 by 2, right? So this 1 by 2 is the power, which is a fraction. Similarly, cube root of b, again this means b to the power 1 by 3, right? So cube root means the third root of b. Square root of a means the second root of a. Similarly, if I have something like 8th root of x, what does it mean? It is x raised to the power 1 by 8. So as you can see in this case, base is a, power is 1 by 2, which is fraction power. In this case, you can see that the base is b and the power is 1 by 3, right? So the surds can also be written in terms of roots, right? Here in this case, the base is x and the power is equal to 1 by 8. So these are the fraction powers and hence these expressions are called surds, right? Now there are certain rules which are common to indices and surds because they are related to simply the powers, not related to the value of the power. Okay. Now there is something called negative power also. Let's see. If we have let's say a to the power minus 3. Now this means 1 upon a to the power 3. If we have 1 upon b to the power minus 2. So if it goes up, it becomes b to the power 2, right? So the powers can be negative also. So when it goes from numerator to denominator, the power becomes negative to positive or positive to negative, right? Similarly, if I have, let's say, a to the power 5, I can also write it as 1 upon a to the power minus 5. If I have a raised to minus 1, it means 1 upon a raised to 1. Or if it is 1 by a raised to minus 1, it can also be a, right? So the powers can be, we have seen the powers can be positive, powers can be fractions, and powers can be negative also. Okay, now let's go ahead. First, let's try and understand the fundamental rules or the most important rules for powers. Okay, rules of powers or indices. Please understand the rules of powers will be applicable to both the integer power as well as the fraction powers, right? So the first rule is very strongly used and that says a raised to the power x into a raised to the power y. This will be equal to, now you see the condition is the base should be same, then only the product can be simplified. And in that case, if the base is same, the base remains same and the powers get added. So a raised to x into a raised to y is equal to a raised to x plus y. So whole power x plus y becomes one single power, a remains the base. Similarly, and this rule can be utilized in both the directions, okay? Depending if the base is same, they can be utilized in both the directions. Second rule, if it is, let's say, a raised to the power x divided by a raised to the power y, what will happen now? The way for multiplication we added, for division we subtract. So the base remains same, the power in numerator comes first, minus the power in denominator. So it is a raised to the power x minus y. So this whole x minus y is the power, a is the base. Alright. So we have a raised to x into a raised to y is equal to a raised to x plus y, and similarly a raised to x upon a raised to y is equal to a raised to x minus y. Now comes the third one, which is a very, very crucial one. If I have a raised to the power x whole to the power y, please be very careful here. A raised to the power x and the whole thing to the power y, then the powers get multiplied. So it becomes a raised to the power x into y. Right? So we have to be really careful. A raised to x whole raised to the power y, it will be a raised to the power x into y. Alright. So these are three most important rules, and all the three rules can be utilized in both the directions depending upon the situation. So a raised to x, a raised to y is equal to a raised to x plus y. A raised to x upon a raised to y, it will be a raised to the power x minus y. A raised to x whole to the power y, it is a raised to the power x into y. Alright. Now let's see further. One more rule can be written as that we have already used, but I'll write it here. A raised to minus x is equal to 1 upon a raised to x. Similarly, 1 upon a raised to x, if it goes in numerator, it will become a raised to minus x. Right? So this is one thing that you need to understand. And the fifth one, we have used it for fractions also, that if I have nth root of a raised to the power m, how do I write it? It is nth root of a. What does it mean? It means a to the power 1 by n. Please understand that 1 by n is the power in this case. Okay. Now just for example, if I want to express something here, let's say what about nth root of a raised to the power m. Now how do we simplify this? Look at this carefully. I'm just giving an illustration here. Nth root of a raised to the power m. This can be written as a raised to the power m whole to the power, because it is nth root, it is power 1 by n. Now the same thing can be from this rule, we can say it is a raised to the power m into 1 by n, which is a raised to the power m divided by n. Right? Now further it can be written as a raised to the power 1 by n into m, which further can be written as a raised to the power 1 by n and whole to the power m. A raised to the power 1 by n and whole to the power m, which is nth root of a whole to the power m. So that means nth root of a raised to m can be written as mth power of nth root of a. Right? So this is a slightly specific situation, peculiar situation. Right? You just see on your own that they can be transformed from the one form to the other. Okay. Now let's go ahead. So we have done 5 rules. Let's take a couple of more rules. Now, suppose we have something like this. A raised to the power x into b raised to the power x. Now here what is happening? Here the bases are different, but the powers are same. In this case what happens? They can be written as a into b whole to the power x. Right? So this is again a very important rule. Please understand that this rule is applicable to all the values of x. Whether x is, it is for all x. So whether x is for all power. So whether the x is positive or negative or fraction, it is useful for all the values. Let's say for example, if it is a raised to x divided by b raised to x. So it will become a by b whole to the power x. Right? Now suppose it is, let's say, root of a into root of b. Now this is a very important one. This is a to the power 1 by 2 into b to the power 1 by 2. Hence we can take it as a into b and whole to the power 1 by 2. Right? Or we can straight away say that it is root of a into b, because power 1 by 2 means root. That means we can directly say that root a into root b is equal to root of ab. Right? So this is one important rule that we can use for a lot of our questions. Alright, so this is where we have completed all the rules related to the indices or the powers. Right? Now we'll take some questions on this. Now we will take up some important values of powers of different bases. Let's say we start from powers of 2. Alright. What we have to see is that we should be able to memorize some of the important numbers. At least we can say the smaller powers of 2. So let's say we know that 2 raised to the power 0. Now anything raised to the power 0 is 1. Now anything raised to the power 1 is equal to itself. So 2 raised to the power 1 is just 2. 2 raised to the power 2. Now it means 2 into 2. So it is equal to 4. 2 raised to the power 3. So it means 2 into 2 into 2. So we already have 2 into 2, that is 4 into 2. So it is 4 into 2, which is equal to 8. Similarly, 2 raised to the power 4. So now we already have 2 raised to 3, that is 8. Multiply one more 2, so you get 16. 2 raised to the power 5, that is equal to 16 into 2, which is equal to 32. 2 raised to the power 6 is equal to 32 into 2, which is equal to 64. 2 raised to the power 7, that will be equal to 64 into 2, which is equal to 128. 2 raised to the power 8, that will be equal to 128 into 2, which is equal to 256. 2 raised to the power 9 is equal to 256 into 2, which is equal to 512. 2 raised to the power 10 is equal to 512 into 2, which is equal to 1024. Alright, so at least up to 2 raised to the power 10 you should memorize. Let me put it as a summary. We have 2 raised to the power 0 is equal to 1, 2 raised to the power 1 is equal to 2, 2 square is equal to 4, 2 cube is equal to 8, 2 raised to the power 4 is equal to 16, 2 raised to the power 5 is equal to 32, 2 raised to the power 6 is equal to 64, 2 raised to the power 7 is equal to 128, 2 raised to the power 8 is equal to 256, 2 raised to the power 9 is equal to 512, and 2 raised to the power 10 is equal to 1024. Now let's look at some interesting things. Here 2 raised to the power 1 is 2, 2 raised to the power 2 is 4, 2 cube is 8, 2 raised to the power 4, look at this, 2 raised to 4 is 16, it is also equal to 4 square. 2 raised to the power 6 is 64, it is also equal to 4 cube as well as 8 square. If you look at 2 raised to the power 8, 256, it is 4 raised to the power 4 as well, and it is also equal to 16 square. 2 raised to the power 9, 512, it is actually 8 raised to the power 3. And 2 raised to the power 10, which is 1024, it is also equal to 4 raised to the power 5, or it is also equal to 32 square. Let me calculate a couple of more powers. So 2 raised to the power 11 is equal to 1024 into 2, that is 2048. 2 raised to the power 12 is equal to 2048 into 2, which is 4096. Now look at this very carefully. This 2 raised to the power 12, which is equal to 4096, it can also be equal to 4 raised to the power 6, 8 raised to the power 4, 16 raised to the power 3, and 64 square. Right? So this is how these calculations become important, because they can be a lot of interconversions among the numbers themselves. Right? So for smaller base like 2, you should try to see that you memorize the values up to powers 10, 11, 12, whatever is possible. You know, the more you do, better it will be. Alright, now let's take the powers of 3. Now for the powers of 3, again, we will not go up to power 12, we will go only up to the power 8. Let's see, 3 raised to the power 0 is equal to 1, 3 raised to the power 1 is equal to 3. 3 square is 3 into 3, so it is 9. 3 cube, that will be 9 into 3, so it is 27. 3 to the power 4, that is equal to 27 into 3, so it is equal to 81. 3 to the power 5, that is equal to 81 into 3, so it is 243, right? 3 raised to the power 6, so it is equal to 243 is into 3, that is 729. 3 raised to the power 7, that is 729 into 3, that is 2187, right? And finally 3 raised to the power 8 is equal to 2187 into 3, which is finally 6561. Right? So if I just make a summary here also, 3 raised to the power 0, that is equal to 1. 3 raised to the power 1 is equal to 3. 3 square is equal to 9. 3 to the power 3, that is equal to 27, that is 3 cube. Now 3 raised to the power 4, it is equal to 81, that also is equal to 9 square. Right? 3 raised to the power 5, that is equal to 243. 3 raised to the power 6, that is equal to 729. As you can see, it is also equal to 9 to the power 3 or 9 cube, and it is equal to 27 square. Alright. 3 raised to the power 7, that is equal to 2187, and 3 raised to the power 8, it is equal to 6561. As you can see, it is equal to 9 raised to the power 4, and it is also equal to 81 square. So here the more important numbers are 729 and 6561, because they can be written in many ways. Alright, so though all the numbers are important, but more important ones are 729 and 6561. Okay, now let's go to the powers of 5. In the same manner, let's say 5 raised to the power 0 is equal to 1. 5 raised to the power 1, that is equal to 5. 5 raised to the power 2 is simply 5 into 5, so it is 25. 5 raised to the power 3, so it is 25 into 5, which is equal to 125. Alright, 5 raised to the power 4, that is equal to 125 into 5, which is 625. 5 to the power 5, that is equal to 625 into 5, which is 3125. 5 to the power 6, that is equal to 3125 into 5, which is 15625. Right? So if you summarize, it is 5 to the power 0 equal to 1, 5 to the power 1 equal to 5. Then 5 to the power 2 is equal to 25. 5 to the power 3, that is equal to 125. 5 to the power 4 is equal to 625, which is also equal to 25 square, right? Then 5 to the power 5 is 3125. Okay, 5 to the power 6 is 15625. If you notice, it is also equal to 25 to the power 3 as well as 125 square, right? Let's look at the powers of 6 and 7 now. Now, powers of 6, if you see, 6 is a big number, so we will not take many powers. Let's take up to 6 raised to the power 4, right? Let's say 6 raised to the power 0, that is equal to 1. 6 raised to the power 1, that is equal to 6. 6 raised to the power 2 is 6 into 6, that is 36. 6 raised to the power 3, that is equal to 36 into 6, which is 216. Alright, so 6 raised to the power 4 is 216 into 6, that is 1296. Just for practice, if you just calculate 6 raised to the power 5, it will be 1296 into 6, which is equal to 7776. And just one more, 6 raised to the power 6 will be 7776 into 6, and that will be 46656. Right? So if I summarize the powers of 6, we can write 6 raised to 0 is equal to 1, 6 raised to 1 is equal to 6, 6 raised to 2 is equal to 36, 6 raised to 3 is equal to 216, 6 raised to 4 is equal to 1296, which is eventually 36 square as well, right? 6 raised to 5, that is equal to 7776, very simple number to memorize. 6 raised to 6 is 46656, and you can notice that it is also equal to 36 cube as well as 216 square. Now let's take the powers of 7. Again, 7 raised to the power 0 is equal to 1. 7 raised to the power 1 is equal to 7. Now 7 raised to 2 is 7 into 7, that is 49. 7 raised to 3 is equal to 49 into 7, that is equal to 343. Okay. And 7 raised to the power 4 is 343 into 7, which is equal to 2401. Just for practice, one more, 7 raised to 5 is equal to 2401 into 7. So it is equal to 16807, right? So if we summarize, it is 7 raised to the power 0 is 1, 7 raised to the power 1 is 7, 7 raised to the power 2 is 49, 7 raised to the power 3 is 343, 7 raised to the power 4 is 2401, which is also equal to 49 square. And 7 raised to the power 5 is equal to 16807, right? So whatever or as much as you can memorize, it will be good for your speed of calculation. All right. So this is just the values. Now on the basis of this, there will be many questions that you can do. Okay. Now let's take up some questions for practice on indices. Right. Let's take up the first question. The first question is 8 raised to the power 2x plus 3 is equal to 2 raised to the power 3x. Right? Now there are two ways to do this. Let's take up the first one. If I write this 8 as 2 cube and whole to the power 2x plus 3 is equal to 2 to the power 3x. We have done the rules, the powers get multiplied. So if we have a to the power x whole to the power y, it becomes a to the power x into y. So here on the left hand side, it will become 2 to the power 3 into 2x plus 3 is equal to 2 to the power 3x. Now as you can see on both the sides, the base is same, that is 2. So the powers can be equated. This means 3 into 2x plus 3 is equal to 3x. Alright, so 3 and 3 get cancelled. We have 2x plus 3 equal to x. Okay, so bring x to the left hand side and 3 to the right hand side. So this gives us 2x minus x equal to minus 3. That is x equal to minus 3. So the required value of x is minus 3. So this is one way of doing this question, right? The other way could have been, I'll write it here itself. The other way could have been, I'll write the equation again. It is 8 raised to the power 2x plus 3 equal to 2 to the power 3x. In the second method, what we could do is, look at the right hand side. It is 2 to the power 3x. This can be written as 2 to the power 3 whole to the power x. So it becomes 8 to the power 2x plus 3 equal to 2 cube is 8 to the power x. Right? So now the bases are same, that is 8. So the powers can be equated. 2x plus 3 equal to x. We'll get the same equation, and on solving we'll get x equal to minus 3. Right? So in any case the answer is going to be the same, but we could have used the base as 2 or the base as 8. Alright, let's take up the next question. Now this question says, simplify this expression, that is 2 into x to the power 1 by 2 raised to the power 3 divided by 4x square. Right, so we have done a rule wherein we say that a into b to the power x, this can be taken as a to the power x into b to the power x. So here we can separate the numerator like this, 2 to the power 3 into x to the power 1 by 2 to the power 3 divided by 4x square. Right, now 2 cube is 8 into this x to the power 1 by 2 to the power 3 can be written as x to the power 3 by 2, the powers get multiplied, divided by 4 into x square. Now 4 cancels 8 2 times, so we have 2 into x to the power. Now 3 by 2 minus 2, so 3 by 2 minus 2, it can be written as, so powers get subtracted because we have a to the power x upon a to the power y. It will be a to the power x minus y. Alright, so this becomes 2 into x to the power minus 1 by 2. Right. Now it depends on the option how it is mentioned. Because the power is negative, it can be sent below, it can be sent in denominator. So it can also be written as 2 divided by x to the power 1 by 2, or it can also be written as 2 divided by root of x. Alright, so these are the 3 ways in which the options can be given. Don't worry, option will be only one of them. Okay, now let's go to the next question. Now this says find x, and the equation is 17 to the power 3.5 into 17 to the power x is equal to 17 to the power 8. This is a very simple question. On the right hand side it will be 17 to the power, the powers get added, so 3.5 plus x is equal to, and on the right hand side it will be 17 to the power 8. Now both sides base is 17, so we can say 3.5 plus x is equal to 8. Right, so very simply x is equal to 8 minus 3.5, which is equal to 4.5. So the answer of this question is 4.5. Okay. Now this question says find x, a by b raised to the power x minus 1 is equal to b by a raised to the power x minus 3. Now please understand, if there is a number k, if it goes in denominator, it can be written as 1 by k to the power minus 1. Right. So in this case, how it is used, let's see, it is a by b raised to the power x minus 1 is equal to b by a raised to the power x minus 3. So this can be written as, let's say a by b to the power x minus 1, we keep left hand side same. But on the right hand side, we say it is a by b raised to the power minus 1 whole to the power x minus 3. So what we are saying is b by a is eventually equal to a by b raised to the power minus 1. Okay. Right, we can directly say that. Why? Because let me put it this way, a by b raised to the power minus 1 is equal to 1 by a by b. Hence it is equal to b by a. So b by a can be replaced as a by b raised to minus 1. So we have a by b to the power x minus 1 equal to a by b raised to the power, now see the powers will get multiplied, minus 1 into x minus 3. Okay. Now you can see the bases are same, a by b and a by b, so the powers can be equated. Okay, so what we will do is, we will say that the power on the left hand side, that is x minus 1, is equal to power on the right hand side, that is minus 1 into x minus 3. Okay, so we have x minus 1 is equal to minus 1 into x minus 3. Simplify, it is x minus 1 equal to minus x plus 3. So this minus x comes to this left hand side, it becomes x plus x, and minus 1 goes to the other side, becomes 1 plus 3. So we have 2x equal to 4, and that means x is equal to 2. So the answer of this question is 2. Alright. Now let's take up this question. It says find the value of x, where is given that 25 to the power 7.5 into 5 to the power 2.5 divided by 125 to the power 1.5 is equal to 5 raised to x. Before going ahead, if you remember, 5 raised to 0 is equal to 1, 5 raised to 1 is equal to 5, 5 raised to 2 is equal to 25, 5 raised to 3 is equal to 125. So here 125 and 25 are going to be used. So let's use that. On the left hand side, we will have 25 can be written as 5 square to the power 7.5 into 5 to the power 2.5. Now this division can be taken like this, divide by 125 to the power 1.5. Okay. So this is equal to 5 to the power x. Now further, in numerator we will have 5 to the power 2 into 7.5, the power gets multiplied, right, into 5 to the power 2.5 divide by 125 can be written as 5 cube whole to the power 1.5, which is already there, is equal to 5 raised to the power x. Now further, what we can do is, it is in numerator it will be 5 raised to the power 2 into 7.5 is 15 into 5 raised to the power 2.5. In denominator it will be 5 raised to the power 3 into 1.5, right, that is equal to 5 raised to x. So what we have here is, in numerator we will have 5 raised to the power 15 plus 2.5, and in denominator it is 5 raised to the power 4.5, that is equal to 5 raised to the power x. This means we have 5 raised to the power 15 plus 2.5 is 17.5 minus the denominator power will go in numerator as a subtraction, 4.5 is equal to 5 raised to the power x. So that gives us 5 raised to the power 13 equal to 5 raised to the power x. Hence the answer of this question is 13, right? Now the next question, it says simplify this expression, right? Here we will be using the powers of 3. If you remember, 3 raised to the power 0 is 1, 3 raised to the power 1 is 9, 3 raised to the power 1 is 3, 3 raised to the power 2 is 9, 3 raised to the power 3 is 27, 3 raised to the power 4 is 81, 3 raised to the power 5 is 243. Right? In exam, you don't have to write all these values. For here you can just see directly, that's why I've written the values here. Now let's look at this expression. This expression can be written as, in place of 243, we can take 3 raised to the power 5 whole to the power n by 5. Okay. Now multiply by 3 raised to the power 2n plus 1. Now divide by 9 to the power n. 9 can be written as 3 square to the power n into 3 to the power n minus 1. Right? So in numerator we have, now this 5 and n by 5 will get multiplied and 5 gets cancelled. So we have 3 to the power n into 3 to the power 2n plus 1. In denominator we'll have 3 to the power 2 into n, that is 3 to the power 2n into 3 to the power n minus 1. So this becomes, in numerator all the powers will get added. So it is 3 to the power n plus 2n plus 1 divide by, in denominator again all the powers will get added. So 3 to the power 2n plus n minus 1. Right? So this can be written as, in numerator 3 to the power 3n plus 1 and in denominator 3 to the power 3n minus 1. Right? So this is 3 to the power, when we take the denominator and numerator, the power gets subtracted. So 3n plus 1 minus 3n minus 1. So what happens, if you open the bracket, it will be 3 to the power 3n plus 1 minus 3n plus 1. So 3n and 3n get cancelled. Be careful about the sign. So it is 3 square, which is 9. So the final answer of this question is 9. Alright. Now let's take the next question. Now this question says, solve for x and y. There is an equation given, 2 raised to the power x plus 3 raised to the power y is equal to 5. And x and y are natural numbers. Right. Okay. So here if you look at this closely, natural numbers means the minimum value of x and y has to be 1. So x and y both have to be greater than 1, greater than equal to 1. Now this is a very easy situation because the minimum we have to take x equal to 1. So if I put x equal to 1, I'm saying if we put, why I'm saying that, because 5 is a very small number, there will not be many possibilities. So if you put x equal to 1, what will happen? If you put x equal to 1, it will become, the equation will become 2 raised to 1 plus 3 raised to y equal to 5. Now 2 raised to 1 is 2, so 3 raised to the power y will be 5 minus 2, which is 3, which is 3 raised to 1. That means y is also equal to 1. So one solution that we get is x equal to 1 and y equal to 1. Right? Now what if I put, if we put x equal to 2, what happens then? If we put x equal to 2, then you can see that it will be 2 square plus 3 raised to y equal to 5. Now 2 square is 4, so 4 plus 3 raised to y equal to 5. That means 3 raised to the power y is equal to 5 minus 4, which is 1. Now 1 as a power of 3 can be written as 3 raised to 0. That means y equal to 0. Now 0 is not a natural number, so we will not take it, right? Further, if we want to put x equal to 3, then 2 cube will become 8, which will be more than 5. So anyways, we are not going to get any natural number value after that. So there is only one solution that is possible, x equal to 1 and y equal to 1. Please understand that this question will be asked only for a small value like 5. Okay, for larger values, we will have many possibilities. So we need one more equation. Now this question was meant to be solved like this only because the values are small. You can directly put and check which one satisfies or what value can satisfy. Right? So the answer of this question is x is equal to 1 and y is equal to 1. Okay, now let's take another question. Now this question, you see that there are two variables x and y. The values are large, very large, and two equations. So what we need to do, there are multiple methods. So let me put as like this. If I say method 1 for this question, what do we do in this? Let's assume that 4 raised to the power x is equal to a and 5 raised to the power y is equal to b. Right? So that means the first equation, let me say like this, first equation can be written like this: 4 raised to the power x plus 5 raised to the power y is equal to 69. This gives us a plus b is equal to 69. Right? Similarly, the second equation, let's say this is the second equation. Now the second equation can be written as, it is 4 raised to the power x minus 1 plus 5 raised to the power y plus 2. That is equal to 141. Now here, 4 raised to x minus 1 can be written as 4 to the power x divided by 4 to the power 1 plus 5 raised to the power y plus 2 can be written as 5 raised to the power y into 5 raised to the power 2 is equal to 141. Now 4 raised to x is a, 5 raised to y is b. So this equation can be written as a by 4 plus 25b, 5 square is 25 and 5 raised to y is b. This is equal to 141. So if you multiply by 4, it will give us a plus 100b is equal to 141 into 4 is 564, right? So these are the two equations, a plus b equal to 69 and a plus 100b equal to 564. This is how, these are the two equations that we need to solve to get values of a and b first. Okay. So I write the equations again. I write the second equation first. A plus 100b is equal to 564. And the second equation is, and the first equation is a plus b equal to 69. Let's do the simple subtraction. A minus b minus 69 minus. So a gets cancelled. 100b minus b is 99b. And 564 minus 69 is 495. Right? And you can clearly see that b will be equal to 495 divided by 99. That gives us 5. Right? So we have b equal to 5. If you put b equal to 5 in this first equation, that is a plus b equal to 69, you will get a equal to 69 minus 5. That means a is equal to 64. But remember, b was 5 raised to y and a was 4 raised to x. So what we need to do is we come back here and we say that b is equal to 5 is equal to 5 raised to y. Now 5 is 5 raised to 1. So we have y equal to 1. Similarly, a, which is equal to 64 in this case, is equal to 4 raised to x, and 64 is actually equal to 4 cube. That means x is equal to 3. Right? So our final answer of the question will be x equal to 3 and y equal to 1. Right? Now this is one method of solving the question where we have used both the equations. We have created linear equation from here. Okay? And we have tried to solve this question. Right? Now the other way does not require solving the equations. Let me take another method for this. Now we'll talk about method 2. Okay. In method 2, we will not use both the equations. We'll use only one of the equations. Let's see how. 4 raised to x plus 5 raised to y equal to 69. Now in this equation, see, we know the powers of 4. Let me put it this. 4 raised to 0 is equal to 1. 4 raised to 1 is equal to 4. 4 raised to 2 is equal to 16. 4 raised to 3 is equal to 64. 4 raised to 4 is equal to 256. Now if you look at this here, it is 69 is the maximum value. So 4 raised to x has to be lesser than 69. That means 256 will not be useful for this equation. But here the value of 4 raised to x can be any one of these things. That is 1, 4, 16 and 64. Let's put one by one. If I put 4 raised to x as 1 plus 5 raised to y equal to 69. From here we will get 5 raised to y as 69 minus 1, that is 68. Now 68 is not a power of 5, so we will not get a suitable value of y here. Right? What we are doing is we are putting the values of 4 raised to x from here. Okay. Now let's take the next one. If I take 4 raised to x as 4 plus 5 raised to y, that is equal to 69. Now this means 5 raised to y from here will be 69 minus 4, that is 65. Now 65 is not a direct power of 5, so this also is not useful. So 1 is not useful, 4 is not useful. Now let's take 16. So if I take 16 plus 5 raised to the power y, this is equal to 69. This will give us 5 raised to the power y equal to 69 minus 16, that is 53. Oh, this also is not giving us any suitable value for y. Okay. Now let's say if I put 64 in place of 4 raised to x, if I put 64, what will happen? So 64 plus 5 raised to y, that is equal to 69. This gives us very clearly that 5 raised to y is equal to 69 minus 64, which is 5, which is 5 raised to 1. That means y is equal to 1. Right? And this was 4 cubed, so x is equal to 3. So please understand that only one equation was sufficient to answer this question. Okay? Now you also need to check the second equation whether it is satisfied by these values or not. If I put x equal to 3 here, put x equal to 3 in this and y equal to 1 in this, what will happen? Let's see. It will become x raised to 4 raised to 3 minus 1. So that gives us 4 square. And 5 raised to 1 plus 2, that is 5 raised to 3. Now 4 square is 16, 5 raised to 3 is 125, that is equal to 141. Right? So that means these values of x and y also satisfy the second equation. Hence, that is the correct answer. Right? So you could have also used the second equation for this. Let me put it this way. If I use only the second equation, then what happens? I'll write the second equation here, 4 raised to x minus 1 plus 5 raised to y plus 2, that is equal to 141. Okay. Now here, I'll use the powers of 5. Let's see how it works. 5 raised to 0 is 1. 5 raised to 1 is 5. 5 raised to 2 is 25. 5 raised to 3 is 125. 5 raised to 4 is 625. Now please see that the addition here is 141. So 625 is higher than 141, so it won't be useful in any case. Now let's put the values of 5 raised to y plus 2 as 1, 5, 25 and 125 one by one and check the values of the other part, how it comes. If I put 4 raised to x minus 1 plus, in place of 5 raised to y plus, if I take 1 equal to 141. So from here, we'll get 4 raised to x minus 1 as 141 minus 1, which is 140. Now 140 is not a power of 4. So this is wrong. So 1 is wrong. Okay. Now let's take the second case, 4 raised to x minus 1 plus 5. If that is 141, then what will happen? From here you can see that 4 raised to x minus 1 is 141 minus 5, that is 136. Even 136 is also not a power of 4. So this 5 is also not correct. Now let's take the next one, 4 raised to x minus 1 plus 25, that is equal to 141. Now what will happen? From here we get 4 raised to x minus 1 is equal to 141 minus 25, that is 116. Now 116 is not a power of 4, so this is also wrong. So 25 is also wrong, right? Next option, that is 4 raised to x minus 1 plus 125 equal to 141. Now this will give us 4 raised to x minus 1 equal to 141 minus 125, that will be 16. Now 16 is 4 square, right? So x minus 1 is equal to 2. So x is equal to 3. Right? And we have taken 5 raised to 3 as 125 here. And here the power of 5 was given as 5 raised to the power y plus 2. That means y plus 2 is equal to 3. So this gives us y equal to 1. So we are going to get the same answer in any case. Alright. But this would be a little faster and better as compared to solving the equations. Okay. Now let's go to the next question. Now this again is a very beautiful question. It says find x, 3 raised to the power x plus 3 minus 3 raised to the power x minus 3 equal to 6552. Again there will be multiple methods. So I'll take first method 1. Look at this carefully. Method 1 is based on direct values. Let's see. One thing is very clear. This value is larger. This value is smaller. Also both of these are powers of 3 and the difference is 6552. That means the first number has to be more than 6552. Let me help you to recall the values of powers of 3. 3 raised to 0 is 1. 3 raised to 1 is 3. 3 raised to 2 is 9. 3 raised to 3 is 27. 3 raised to 4 is 81. 3 raised to 5 is 243. Right? 3 raised to 6 is 729. 3 raised to 7 is 2187. 3 raised to 8 is 6561. 3 raised to 9 is 19683 and so on. Now here we are saying that this first value has to be more than 6552 and has to be a power of 3. Here if you see, the first value that is more than 6552 in this case is 6561. Oh, so let's do one thing. Let's, in place of 3 raised to x plus 3, put 6561. Let's check what happens. So if I take 6561 minus 3 raised to the power x minus 3 equal to 6552. So what we are saying here is, we are taking 3 raised to the power x plus 3 as 6561. Right? Now from here, what we get? 3 raised to x plus 3 equal to, we know that 6561 is 3 raised to 8. So we get x plus 3 equal to 8. That is x equal to 5. Now we don't know whether it is correct or not. That will be confirmed from here. How? Let's see. Bring 6552 this side. So it becomes 6561 minus 6552. That is equal to 3 raised to the power x minus 3. Now 6561 minus 6552 is 9. Subtract normally. That is 3 raised to the power x minus 3. Now 9 is 3 square. So 3 square is equal to 3 to the power x minus 3. So 2 is equal to x minus 3. From here also you get x equal to 5. Right. That means this x equal to 5 is a correct answer. Oh, so 6561, our assumption that we started with is correct. Right? So this is one good way of doing the question, if at all you remember this. See, if you don't remember this, then in the exam doing this whole thing will consume a lot of time. So then it won't be useful. This method is useful only if you directly memorize that above 6552, there is a power of 3, that is 6561, which is definitely difficult. Hence, the second method. Let's look at the second method now. Now, in the second method, what we do, we follow the normal procedure. Normal procedure as in 3 raised to the power x plus 3 can be written as 3 raised to the power x into 3 raised to the power 3 minus 3 raised to the power x minus 3 can be written as 3 raised to x divided by 3 raised to the power 3 is equal to 6552. Let's take 3 to the power x common. 3 cube is 27 minus 1 by 3 cube is 1 by 27. That is equal to 6552. So from here we get 3 raised to the power x into, in denominator 27, in numerator 27 into 27, that is 729 minus 1, that is equal to 6552. Alright. Now this gives us 3 to the power x into 728 divided by 27 is equal to 6552. If you look at this closely, 8 9s is 72. So in fact 728 cancels 6552 9 times. So we have 3 raised to the power x is equal to 27 into 9. Now 27 is actually 3 cube, 9 is 3 square, right? So the powers on the right hand side get added. We have 3 raised to x is equal to 3 raised to 3 plus 2, which is 3 raised to 5. So this tells us very clearly that the value of x is equal to 5. So this was one conventional method, not very difficult method. This is also useful. Alright. I am so sorry. This was question number 9 actually. Okay. Now let's take up one more question. This question says 5 to the power x plus 3 minus 5 to the power x minus 3 is equal to 78120. Now this is a very interesting question. Here also you can use the powers of 5. That will be really difficult to do. Okay. But let me give you all the methods. So first, method 1. Okay, if I give you the method 1, as I said, the values based method, that is 5 raised to 0 is equal to 1, 5 raised to 1 is equal to 5, 5 raised to 2 is equal to 25, 5 raised to the power 3 is equal to 125, 5 raised to the power 4 is equal to 625, 5 raised to the power 5 is equal to 3125, okay, 5 raised to the power 6 is 15625. Okay, 5 raised to the power 7 is 78125, right? You know, just by looking at the 78125, it should strike that 78120 is slightly below 78125. Now here, something minus something we are getting 78120. That means the first value has to be more than 78120 and also it is a power of 5. So what we will do, we will assume it to be 78125. So let's assume that this is 78125. Minus 5 raised to the power x minus 3 equal to 78120. So what we are saying that we are assuming 5 raised to the power x plus 3 equal to 78125. That means we are assuming 5 raised to the power x plus 3 to be 5 raised to the power 7. So this gives us x plus 3 equal to 7, that is x equal to 4. Right? Let's check from the second part whether it is correct or not. Okay. Now from this equation, bring the 78120 to this side. This will become 78125. Minus 78120, that is equal to 5 raised to the power x minus 3. Now 78125 minus 78120 is actually 5. That is 5 raised to the power x minus 3. Now 5 is 5 raised to 1. So 1 is equal to x minus 3. Right, so that means x equal to 4. So from both the places we are getting x equal to 4 only. Hence this is the correct answer. Right? Again, not very difficult to understand, but you have to memorize the values to be able to use this. Okay, now let's take second method for the same question. Now we take up method 2 for the same question. Let's see how it goes. The normal conventional process, separate them. So 5 raised to the power x into 5 raised to the power 3, because the power is x plus 3. Second one, 5 raised to x minus 3. It can be written as 5 raised to the power x divided by 5 raised to the power 3 equal to 78120. Right? If you take 5 raised to the power x common, you will have 5 raised to 3, that is 125, minus 5 raised to x has gone out. So 1 upon 5 cube, that is 125, equal to 78120. So this gives us 5 raised to the power x. LCM is 125. In numerator, we'll have 125 into 125, that is 125 square, that is 15625, minus 1 equal to 78120. So this gives us 5 raised to the power x into 15624 divided by 125 equal to 78120. Now look at this closely. 5 4s is 20, 15 5s is 75. In fact, 15 6 24 cancels 78120 5 times straight away. So from here we have 5 raised to the power x is equal to 125 into 5. Now 125 is actually 5 cube. 5 itself is 5 raised to 1, so which is 5 raised to the power 3 plus 1, that is 4. So 5 raised to x is equal to 5 raised to 4. So this tells us very clearly that x is equal to 4. So this was the other way, the conventional way of doing this. But even in this, you have to utilize this calculation of 15625. Okay. So in any case, calculation has to be done. See, wherever it is necessary, you have to do that calculation. Okay. Now, in this particular question, only in this particular situation, there is another thing that I should point out. Let's see. I'll say it is method 3 for the same question. Alright. Now, in this method, there is a very beautiful information that is used. If you remember the powers of 5, 5 raised to 0 is 1, 5 raised to 1 is 5. But after this, all the powers have 25 in the end. 5 square, 5 cube, they all have 25 in the end, right? I'll just write a couple of them. So all of them will have 25 for sure. Now here, x plus 3 is a very large number as compared to x minus 3. That means 5 raised to x plus 3 will definitely be more than 5 square. Right? So this value definitely ends in 25. Now, if this value also had ended in 25, then after subtracting, we must have got 0, 0 in the end, which we have not. We have 20 in the end. What does it mean? It means 5 raised to x minus 3 cannot have 25 in the end. Now, if 5 raised to x minus 3 cannot have 25 in the end, then there are only two possibilities. It will be either 5 or 1. It will be either 5 raised to 1 or 5 raised to 0. There is no other possibility. Alright? I'll repeat in a different manner. We are saying that this 5 raised to the power x plus 3 is definitely going to have 25 in the end because it is a large power. Right? But 5 raised to x minus 3 has to be such a in such a number that after subtracting, we should get 78120. That means we should get 20 here. So by looking at this, you can be sure that in place of the second number, we will have something that has 5 in it. Only 5 in it. Then only after subtraction we will have 20. We cannot take 1 because 25 minus 1 will be 24. Here it is 20. So we must take the second number as 5. So from here only we can say for sure that 5 raised to x minus 3 has to be 5, which is 5 raised to 1. Okay, so x minus 3 is equal to 1, that is x equal to 4. But please understand that this was a very specific step only for this particular situation because of this 20. Okay, so we don't have to get into these detailed values of 5 raised to x plus 3. Whatever it is, it will always have 25 in the end. Second number should be such that after subtraction we should get 20 here. The only one possibility for the second number is that it has to be simply 5. That's it. So the answer of this question is x equal to 4. Alright. So this is where we have completed a good number of questions related to indices. Now let's take up some questions based on comparison for indices. Right. Let me put it this way. Let me start with a question like this. 3 raised to the power 5 and 5 raised to the power 3. Which one is larger? Here you can use the values. Right. So you can simply compare that 3 raised to 5 is 243. 5 raised to 3 is 125. Now 243 is greater than 125. So 3 raised to 5 is greater than 5 raised to 3. Right. So this is the answer. Similarly, if I say what is 5, which one is greater, 5 raised to 7 or 7 raised to 5? Now for this one, you need the powers of 5. There is 5 cube is 125, 5 raised to 4 is 625, 5 raised to 7 is 78125. Right. So 5 raised to 7 is 78125. Similarly, you can check the powers of 7, right? 7 raised to 4 is 2401. 7 raised to 5 is 16807. So here it is 16807. You can clearly see that 78,000 is greater than 16,000. So 5 raised to 7 is greater than 7 raised to 5. So this also we could do. What we are doing here is we are using the values, right? But these are, please understand, the 3, 5, 7, these are smaller values. Okay, so for them you could actually check the powers, but if the values are larger, then what will you do? Let's say, for example, which one is greater out of 15 raised to 17 and 17 raised to 15? Now this will be really difficult. You cannot depend upon the values. You cannot calculate the values in a shorter duration. Okay, so what you must do? Let's go back and check these values again. Here the pairs are 3 raised to 5 and 5 raised to 3. Oh, so that means we are just reversing the number and the power, reversing the positions of numbers and the power, base and the power. Like say in this case it is 5 raised to 7 and 7 raised to 5. What we are doing is we are putting the base in the power and the power in the base, right? So here also 15 raised to 17 and 17 raised to 15. Just by looking at these two relations, you can see that 15 raised to 17 will be greater than 17 raised to 15, right? Whenever the smaller base has a higher power, will be the higher number. Right? So whenever we have two numbers in which number and the power, the base and the power are being interchanged, then that number will be larger, which has a smaller base and higher power. All right. Let me put it this way. Let's go to the smaller numbers, very small numbers. Okay. Let's start from 1 raised to 2 and 2 raised to 1. We know 1 raised to 1 is 1, 2 raised to 1 is 2. So definitely 2 raised to 1 is greater. Oh, so just now whatever rule we said is not working out here. Okay, let's see. Go ahead. 2 raised to 3 and 3 raised to 2. 2 raised to 3 is 8, 3 square is 9. Oh, so 9 is greater than 8. Still the same rule is not working. Don't worry, go ahead. Let's take 3 raised to 4 and 4 raised to 3. Now 3 raised to 4 is 81, 4 raised to 3 is 64. So 3 raised to 4 is greater, right? Now here onwards, let's check another one. 4 raised to 5 is 1024. 5 raised to 4 is 625. So this is greater. Please try and understand that these two are the only exceptional relations, right? Okay. Other than these two, always the smaller base to higher power will always be greater than higher base to the smaller power, right? So look at this condition very carefully. The same two numbers should be repeated, right? So if it is a raised to b and b raised to a, only in such cases, if a is smaller than b, then a raised to b is greater than b raised to a. Just remember, smaller base, higher power will always be greater for the same pair of numbers, right? The only exceptions are 1, 2 and 3. 3 onwards, if the numbers are more than 3, right, and 3 onwards, this rule will follow. Okay, both a and b should be greater than or equal to 3. Right, so this rule can directly be utilized. If any one of them is less than 3, this rule will not work, like in these two cases. In fact, these are the only two cases where it won't work. Okay, say for example, let's say 2 raised to 4 and 4 raised to 2. 2 raised to 4 is 16, 4 square is 16. Oh, so both are equal. So this is actually the limiting condition. Right, but here also the rule is not working. So this also can be taken as an exceptional relation. So these are the only 3 exceptional relation. Otherwise, always smaller base to the higher power for the same pair of numbers will always be the larger. So for example, if I have 13 raised to the power 15 and 15 raised to the power 13, without any confusion, 13 raised to 15 has to be the greater one. Okay. Let's say suppose we have 99 raised to the power 100, 100 raised to the power 99. Without any confusion, 99 raised to 100 has to be greater than 100 raised to 99, right? Let's say even if we get a very close situation like this, if I have 99.99 whole to the power 100.01 and 100.01 to the power 99.99, nothing to worry. Clearly 99.99 to the power 100.01 will be greater. Right? So these questions will, even though they look like difficult ones, they are really, really easy questions. You can answer them just by looking at them. Okay. Now on the basis of this, let's take an example. Now, let's take up this question. It says, arrange the following numbers in ascending order. Let's say this is A, this is B, this is C, this is D. Right? We have to arrange them in ascending order. Alright. Now here A is 3,333. No problem. Let's look at B. B is 333 cube, right? B is 333 cube. Now, if you see, even the square of 300 is more than 90,000 or is around 90,000. Here it is only 3,000. So definitely A is less than B, right? Only the square would be much higher than 90,000. So cube will be much bigger. So A is less than B. All right. Also, we can compare B and D directly. We can compare B and D directly. How? Let's see. B is 333 to the power 3. D is 3 to the power 333. So just now the rule that we did, on the basis of that, the number for the same pair of numbers, here the numbers are 333 and 3. 3 and 333. So that number which has a smaller base and higher power, for such combination will always be greater. Right? So clearly D is greater than B. So we have placed three numbers A, B and D. Now let's compare BC and CD. Now let's compare C and D. Is given C is equal to simply 33 raised to the power 33. Right? See, when we have to compare two numbers, either you make sure that the bases are same or you make sure that the powers are same. Right? Here the bases are 33 and 3. Right? So we may not be able to make the bases same. Let's try to make the power same. How do we do that? Let's see. D is equal to 3 to the power 333. 333 in the power can be written as 330 plus 3. That means it is 3 to the power 330 into 3 to the power 3. Right? Now 330 is 33 into 10. So D can be taken as 3 to the power 33 into 10 into 3 cube is 27. So it is 3 to the power 10 whole to the power 33 into 27. Right? Whereas C was 33 to the power 33. Right? Now look at this carefully. I'll write it again here. We have C equal to 33 to the power 33. Whereas D is equal to 3 to the power 10 to the power 33 and that too multiplied by 27. Even if I ignore this 27, here the powers are same 33, 33. Try and see that which one is greater, 33 or 3 raised to 10. If you compare 3 raised to 10, would start laughing, okay? Because 3 cube is 27, 3 raised to 4 is 81. 3 raised to 10 is definitely going to be more than 33. Right? 3 raised to 10 is definitely going to be much greater than 33. That means D is greater than C. Right? So we already had this situation where A was the smallest, then B, then D. Now D is greater than C. So now to place C, we need to identify the place of C with respect to B also. Okay, let's take up now. Now B was equal to 333 to the power 3. Right? Let it be like this only. What about C? C is equal to 33 to the power 33. Now here just do one break. Let's write the power as power 33 as 11 into 3. So this means this C can be taken as 33 raised to the power 11 whole to the power 3. Right? Now compare B and C. The powers are same, 3 and 3. Look at 333 and 33 to the power 11. We know that 33 square only is 1089. Right? So 33 power 11 will definitely be greater than 333. So their cube, that is B, will definitely be less than C. Right? So what all do we have now? We have C less than D, we have B less than C, and we have A less than B. So finally, the ascending order, the correct ascending order is A less than B less than C less than D. So this is the answer of this question. Alright. So this way we could have utilized that rule that smaller base to the higher power for a combination of a situation where the power and the base are interchanging will always be greater when the base is smaller, power is higher. Alright. Now let's take one more question in this. For the next question, I'll just explain something called binomial theorem a little bit. It will help you. Don't worry, it is a simple rule. You already know a couple of them. Let's say, for example, x plus y whole square. We know it is x square plus 2xy plus y square. Right? This is an example of binomial theorem. Right? Let's say x plus y whole cube. Right? Just make sure that you have to write in the complete expanded form. Right? And the power of x should be higher in the beginning and then it should keep reducing and power of y should be maximum in the end. So x plus y whole cube is x cube plus 3x square y plus 3xy square plus y cube. Right? Now if I generalize this, look at first two terms or maybe the first three terms. What is happening? if I take x plus y raised to the power n, what will happen? Just look at it. The first term will be x raised to the power n. Similarly, the last term will be y raised to the power n, though we do not need it. Right? Come back to the second term. Second term, look at this closely, like this power 2 was here, it came to the coefficient of second term. Power 3 was here, it came as the coefficient of second term. So here in x plus y raised to n, first term will be x raised to n, second term will be n into x to the power. You see the power is reducing, so here power 2 and then became 1. Here power 3 then became 2, so it will be x raised to n minus 1. And y appears, so it is just y. Alright. So it is x raised to n plus n into x raised to n minus 1 into y. Okay. And the next term I am telling you that it is going to be n into n minus 1 by 2 into x raised to n minus 2 into y square, and so on. It will go on. It will continue. Right. Now for our questions, only the first two terms are important. Right. If you memorize the third term, it is good. Right. So I repeat, x plus y whole to the power n. Just memorize that the first term is x raised to n plus second term is n, x raised to n minus 1 y, and the third term is n into n minus 1 by 2 into x raised to n minus 2 into y square. Right? You don't need to go further. Okay, just memorize these three terms. Now how will this be helpful in questions? I'll show you now. Let's take up. Suppose the question says which one is greater, right? Out of 13 raised to the power 19 and 16 raised to the power 18. Alright. Now out of these two, which one is greater? Now this we cannot do directly, right? Because here the base and the power are not interchanging. So this we cannot do directly. So what we need to do is, let's see, write both the numbers separately, 13 raised to 19, 16 raised to 18. Now create a new number with smaller base and smaller power. Create a new number with smaller base and smaller power. Now here, out of these two, which one is the smaller base? It is 13. Which one is the smaller power? That is 18. So just think about this new number, create it from your side and divide by this 13 to the power 18 every number. So divide every number by 13 raised to 18. Divide this also by 13 raised to 18. Now what will happen? 13 raised to 19 upon 13 raised to 18 will become equal to 13 raised to 19 minus 18, which is 13. Right? What we have done is we have divided by the same number. Okay. Now this one will become 16 by 13 raised to the power 18. Now 16 by 13 can be written as 13 plus 3 divided by 13 whole to the power 18. So this 16 to the power 18 upon 13 to the power 18 becomes 1 plus 3 by 13 raised to the power 18. And here you can apply this rule, binomial theorem, x plus y raised to n. Here x is 1, y is 3 by 13 and n is 18. So it will be, the first term is 1 raised to 18, which is 1. Okay. Plus second term will be 18. In place of n we have 18 into x, that is 1 raised to 18 minus 1, that is 17, into y, that is 3 by 13. Third term would be 18 into 17 by 2 into 1 raised to 16 into 3 by 13 square. Alright, and so on. We don't need to go further. Okay. I'll tell you the reason also why we don't need to go further. Let's see here. Now 1 raised to 18 becomes 1 plus 18 into 1 into 3. That is 54 by 13 plus 18 into 17. 2 cancels 18 9 times. 9 into 17 is 153 into 3 square is 9 divided by 13 square is 169. Now after this, the numbers will have higher powers of 3 raised to 13. Right? Now the higher powers of 3 raised to 13 will become very, very small. So we can ignore them. Right? Now let's calculate the remaining values. So it is 1 plus 54 by 13. If you divide with simple division, you will get 4.154 plus. If you multiply 153 into 9 by 169 and divide by 169, you see you will get 8.148 and so on. There will be still some more terms, but nothing to worry, because they are going to be very, very small. Now you see, if you add these values, let's see, 1 plus 4 is 5 plus 8, 13. Oh, so it is going to be 13.30 something and still something more. Alright, so as you can see, this 13.30, this has come from 16 raised to 18, and this 13 had come from 13 raised to 19. Very clearly 13 is smaller, 13.3 is larger. Okay, so we can say very safely that this 13 is smaller than 13.3. That means 13 raised to 19 is smaller than 16 raised to 18. Right, so 16 raised to 18 is greater, 13 raised to 19 is smaller. Right, see, some questions will be difficult, some questions will be easy also. I'll show you another example of this. Let's take up, suppose we have to find which is greater out of, let's say, 12 raised to the power 20 and let's say 15 raised to the power 19. Now this will be really easy. Let's see. How do we go about it? We take up both the numbers, right? And we divide both of them by a new number. And how do we decide the new number? New number has to be small base out of the given bases and the small power out of the given powers. Small power out of the given powers. So here the small base is 12 and the small power is 19. So it is 12 raised to 19 by which we will divide. So what will happen? The first number, if you divide by 12 raised to 19, it becomes 12 raised to the power 20 minus 19, which is 12 raised to the power 1, which is 12. So the first value is 12. Look at the second one. If you divide the second one, that is 15 raised to 19 by 12 raised to 19, what will happen? It will give us 15 by 12 whole to the power 19. Alright. Now 15 by 12 is actually 5 by 4 whole to the power 19. Now 5 by 4 can be written as 4 plus 1 upon 4 to the power 19, and that is 1 plus 1 by 4 raised to the power 19. Alright, so this can be written as, this can be taken as, if I apply the binomial theorem again, it is first term is 1 raised to 19, second term is 19 into 1 raised to 18 into 1 by 4, third term is 19 into 18 by 2 into 1 raised to 17 into 1 by 4 square, and after that we'll get higher powers of 1 by 4 which will be much smaller, so we don't need to worry about them. Okay, so if you simplify this, you will get 1 raised to 19 as 1. Second term is 19 into 1 divided by 4. 19 divided by 4 will be 4.75, right? Plus the next one is 2 divides 18 9 times. 19 9 is 171 into 1 by 4 square is 1 by 16, right? Now 171 divided by 16 is almost 10, alright? Or in fact a little more than 10. Even if I just take it to be 10, no problem, because it is 1 plus 4.75 plus 10 plus something more, which is clearly 10 plus 4 is 14 plus 1 15 or close to 16, so 15.75. So very clearly 15.75 is greater than 12, right? So this means, we can very safely say now 15.75 came from 15 raised to 19 and 12 to the power 20, this 12 came from 12 to the power 20, right? So very clearly you can see that 15 raised to 19 is greater than 12 raised to 20. Okay, so this is how we can solve such questions, right? In some questions the reverse can also happen. Let's take another one. Suppose we say find which is greater out of, we take 41 raised to the power 49, alright, and 43 raised to the power 47. Let's see, let's look at this. Decide the smaller base, smaller power, so 41 raised to 47. So 41 raised to 49 divide by 41 raised to 47. This will become 41 raised to 49 minus 47. This is 41 square. Now 41 square is 1681. Let it be. Whereas the second one, that is 43 raised to 47 divide by 41 raised to 47. This will be, you see, it is 43 upon 41 whole to the power 47. The numerator 43 can be written as 41 plus 2 divided by 41 whole raised to the power 47. So this becomes 1 plus 2 by 41 to the power 47. Now here it is 1 raised to 47 plus 47 into 1 to the power 46 into 2 by 41 plus 47 into 46 by 2 into 1 raised to 45 into 2 by 41 square. Right? Now look at this closely. This 1 raised to 47 is 1. 47 into 2 is 94 upon 41 is close to 2.2 or 2.3 maybe. Plus 2 cancels 46 23 times. Right? 47 into 23 divide by, and then this is 47 into 23 into 2 square is 4 divide by 41 square. So 41 into 41. So even if you look at this, 47 upon 41 is close to 1. 23 4 is 92 divided by 41 is close to 2. So this value cannot be more than 2.5. So here we have 1 plus 2.3 plus 2.5 and further much smaller values. Why smaller? Because the power of 2 by 41 will keep on increasing. So that value will keep on reducing. So this cannot go beyond 5 or 6. Okay, so this is 5.8 approximately. This is not going beyond 6 or 7. Here it is 1681. So very clearly the number which gave us 1681 is higher than this number. Now this 5.8 came from 43 raised to 47, right? And this 1681 came from 41 raised to 49. So in this case, 41 raised to 49 is much greater than 43 raised to 47, right? So this was a simple way of doing such questions. All right, now let's go to the next type of questions. Now let's take up some questions on Surds. All right, the questions on Surds can be divided into three categories. The first category is the questions related to comparison. Okay. Second category of questions will be based on a rationalization of irrational numbers. We'll take all of them one by one. And the third category of questions is based on finding the square root of irrational numbers. Square root of irrational numbers. Okay. Now let's take one by one. First, we'll start from the questions related to comparison. Now let's take up the first question. It says, arrange the following numbers. Numbers are root 3, cube root of 7, fourth root of 12, and sixth root of 20. Right? Now we have to arrange them in, let's say, in ascending order. All right, let's give them some name. Root 3 is, let's say, A, the cube root of 7 is B, fourth root of 12 is C, and sixth root of 20 is D. So we have to arrange A, B, C, D in the ascending order. Now how do we go about it? Let's see. First, let's write them in terms of powers. Square root of 3 can be written as 3 to the power 1 by 2. Cube root of 7 can be written as 7 to the power 1 by 3. Fourth root of 12 can be written as 12 to the power 1 by 4. And sixth root of 20 can be written as 20 to the power 1 by 6. As we have studied earlier, that nth root of A is actually A raised to the power 1 by n. Okay. Now here, look at the powers. The powers are 1 by 2, 1 by 3, 1 by 4, and 1 by 6. Look at the denominator of the powers, 2, 3, 4, and 6. Let's make them equal. And how do we make them equal? We calculate the LCM of 2, 3, 4, 6. The LCM of 2, 3, 4, 6 is 12. Now, to make 12 in all the denominators, how do we make it? Let's see. This 1 by 2 can be written as 6 by 12. So it is 3 to the power 6 by 12. This 7 to the power 1 by 3. This can be written as 7 to the power 4 by 12. We are saying that 1 by 3 can be written as 4 by 12. Then this 1 by 4, this can be written as 3 by 12. And this 20 to the power 1 by 6 can be written as 20 to the power 2 by 12. Now, these numbers, all of them can be written as, let's see, 3 to the power 6 by 12 can be written as 3 to the power 6 whole to the power 1 by 12. 7 to the power 4 whole to the power 1 by 12. The next number can be written as 12 to the power 3 whole to the power 1 by 12. And next number can be written as 20 square whole to the power 1 by 12. Because we also know that a raised to the power x whole to the power y is equal to a to the power x into y. And this applies both ways. Right? So now this 3 raised to 6 is 729 to the power 1 by 12. 7 raised to 4 is 49 square, that is 2401 raised to the power 1 by 12. 12 cube is 1728 raised to the power 1 by 12. 20 square is 400 raised to the power 1 by 12. Right? You see, in this situation, all these numbers have the same power. Right? So the number which has smaller base will be smaller, the number which has higher base will be higher. Right? Here 2401 is the highest. Right? 400 is the smallest. Okay, so if I have to arrange them in the order, if this was A, this was B, this was C, this was D, then the ascending order for these numbers will be given as, the smallest will come first, that is D is the smallest, then it is A, then larger than A it is C, and the largest would be B. So this is the ascending order answer for this question. Okay. So this was one very beautiful method. What we need to do, see, understand, in any case what we have to do is, we have to either make the bases equal or the power equal, right? We can compare two numbers only when either the bases are equal or the powers are equal. When both are different, then the question will become very difficult, and in our exams we will not be asked such questions. We will be asked such questions where we can either we can equate the base and compare the powers, or we can equate the power and compare the bases. Here we have equated the power, we have made all the powers equal to 1 by 12, right? And then we have compared the bases. On that basis, the answer is D smallest number, then A larger than D, then C larger than A, and B is the largest number. So this is the ascending order in this particular case, right? Let's take one more question. Now, this question says, arrange the following numbers in ascending order, right? Let's say the first number is A, that is root 7 plus root 17. Second number is root 10 plus root 14, let's call it B. Third number is 3 plus root 15, let's call it C. And 4 plus 2 root 2, that is D, right? We will use a formula, that is x plus y whole square. We know that it is equal to x square plus y square plus 2xy. Now, how do we use it here? Let's see. What we will do is we'll square all of these numbers. Now, what will be the square of A, the first one? Root 7 plus root 17. Let me write it properly. Root 7 plus root 17 whole square. Now, from this formula, x square plus b square plus 2xy, what do we get? Root 7 square is 7. Root 17 square is 17 plus 2 root 7 into root 17. This gives us 7 plus 17 is 24 plus 2 root 7 and 17 will be multiplied, right? We have studied earlier that root of A into root of B can be taken as root of A into B, right? So they'll combine and give us 7 into 17, that is 119. This is the square of the first number, all right? Now the second number, what will be the square of this number? Let me write it again. Root 10 plus root 14. If you take the whole square, root 10 square is 10, root 14 square is 14 plus 2 root 10 into root 14. This gives us 10 plus 14 is 24 plus 2 root 10 into 14 is 140, right? So this is the square of the second number, okay? The third one, 3 plus root 15 whole square. Now you see it will be 3 square is 9. Root 15 square is 15 plus 2 into 3 into root 15. Now let's do one thing. Send this 3 inside the root. Now when 3 goes inside the root, it becomes 3 square. So it becomes 9 plus 15 is 24 plus. Now 3 goes 2 times, 3 goes inside, becomes 9. 9 into 15 is root 135. Right? I will write it separately. Let's say here. When I say 2 into 3 root 15, what we do is we send this 3 inside the bracket. When it goes inside, it becomes 3 square, right? Now 3 square is 9, so it is 2 into 9 into 15, and 9 into 15 is 135. So that is what we have used here. The fourth one, that is 4 plus 2 root 2 whole square. 4 square is 16. 2 root 2 square will be 2 into 2 square is 4 and root 2 square is 2, so it is 8. Plus 2 into 4 into 2 root 2, right? Now here again, this 4 into 2 is 8. Let this 2 be here. See, we want 2 in every number, right? So this 2 be here. This 4 into 2 is 8. 8 goes inside, becomes 8 square, that is 64. So we have 16 plus 8, that is 24, plus 2 times root of, now 4 into 2 is 8. 8 goes inside, becomes 8 square. 8 square is 64 into 2, that is 128. All right. So this is 24 plus 2 root 128. I'll just show how we got this 2 into 4 into 2 root 2. This is actually 2 into 4 into 2 is 8 root 2. This 8 goes inside the square root, so it becomes 2 into root of 8 square into 2, which is 2 into square root of 8 square is 64 into 2, that is 128. So it is 2 root 128. All right. This is how we got this 2 root 128. Now, these are the squares. These are the square numbers. Look at them carefully. Here you see 24 is the first part in each number, then plus 2 times is there in each number, then square root of different numbers. So whichever number has a smaller number inside square root will be smaller, and whichever number has a higher number inside the square root will be higher. So from here you see 24 is same, 2 is same. So inside the square root the smallest is 119, right? And the largest is 140, right? So very clearly you can see that the ascending order will be given as the smallest was this one, that is root 119, and that came from A. So it will be A first. Then larger than A, let's look at the number or find the number which is more than 119. Now more than 119 is 128. So the second place will be 128. This has come from D. So it is D. Then the next number would be more than 128 is 135. So that has come from C. So it is less than C. And then largest one that has come from B, because it is 140 is come from B. So it is B. So the ascending order is given as A less than D less than C less than B. See, in your exams the questions will be asked like this only. It'll either be the first part same or the second part same, right? So if one of the parts is same, then it's very easy. It becomes very easy to compare which number is larger and which number is smaller. So this is how the questions will be asked from you. Alright. Let's take one more question on comparison of surds. Let's say we have A is equal to root 17 minus root 15 and B is equal to root 13 minus root 11, right? Which one is greater? We have to find which one is greater. Now, here we have minus sign. Earlier the question that we did, we had plus sign, root 17 plus root 15 kind of numbers were there. But here we have root 17 minus root 15. Please be careful that the method will not be the same as we did earlier. Here what we need to do is, we need to multiply by the conjugate in numerator and denominator. So this A, which is equal to root 17 minus root 15, just multiply by the conjugate of that number, that is root 17 plus root 15, and divide by root 17 plus root 15, right? So this A becomes in numerator it will be root 17 minus root 15 into root 17 plus root 15. That will be x minus y into x plus y, which is x square minus y square. So it is root 17 square minus root 15 square. Divide by root 17 plus root 15. I repeat, whenever there is a minus sign, you simply multiply by the conjugate in numerator and denominator. So in numerator, we will have 17 minus 15 divided by denominator will be root 17 plus root 15. The purpose is to get an irrational number with a plus sign. So A is equal to 2 divided by root 17 plus root 15. Right? So here in denominator, we have an irrational number which has a plus sign in it. Alright? And numerator is 2. Now let's look at the other number, that is B. So B is root 13 minus root 11. Right? Follow the same procedure. The same B can be taken as root 13 minus root 11 multiplied by root 13 plus root 11 divided by root 13 plus root 11. Right? So what happens? We get B equal to root 13 minus root 11 into root 13 plus root 11 will be root 13 square minus root 11 square. And in denominator we will have root 13 plus root 11. Alright, so B is equal to root 13 square is 13, root 11 square is 11 divided by root 13 plus root 11. So here also we have 2 in the numerator and denominator is an irrational number with plus sign. Right? Now we have to compare A and B, and now we can do that very easily. Let's see. Look at this A and B very carefully. The numerator is same, that is 2. Right? Now whichever has a larger denominator, that number will be smaller. Right? Larger denominator, that means the number smaller. Now look at the denominators. What are the denominators? Denominators are root 17 plus root 15 in the first one and root 13 plus root 11 in the second one. Very clearly, you can see that root 13 is smaller than root 17, root 11 is smaller than root 15, so their sum will definitely be smaller than this whole thing. So we can say here, just by looking at it, that root 17 plus root 15 is greater than root 13 plus root 11. Right? I repeat, see, here we have root 17, we know it is greater than root 13. We also know that root 15 is greater than root 11. Right? Inequalities can be added. right? They cannot be subtracted, but they can be definitely added. So if I add the numbers on right and left hand side, it will be root 17 plus root 15, and it will be greater than root 13 plus root 11. So remember, inequalities can be added only when they have the same sign, and they can be only added. They cannot be subtracted or any other thing, right? So root 17 plus root 15 is definitely greater than root 13 plus root 11. Now this means that 2 divided by root 17 plus root 15 will be less than 2 divided by root 13 plus root 11. Why? Because if the denominator is high, the number is small. Okay. So this shows that A is less than B. Alright. So here the answer is A less than B. So this was a much simpler question actually. Alright. Now let's go to the next category of questions. Now this part is based on the questions based on rationalization. Now what is the meaning of rationalization? This situation comes up only when there is an irrational number in the denominator. Let's take an example, 1 upon 2 plus root 3, right? The rationalization means that in denominator we make sure that there is no irrational number. We make it rational. How do we do that? We multiply by something in the numerator as well as in denominator. Now whatever we multiply by is called conjugate, right? Now what is the meaning of conjugate? Let's see. If there is a number of the form root x plus root y, its conjugate will be root x minus root y. Similarly, if there is a number of the form root x minus root y, its conjugate will be root x plus root y. Just understand that you have to change one sign of just one of them, right? So if it is root x plus root y, its conjugate will be root x minus root y, or it may be root y minus root x also, depending upon the situation we'll take. Similarly, for root x minus root y, the conjugate will be root x plus root y. You have to change sign of only one of them. So for example, in this question, if it is 1 upon 2 plus root 3, then we have to multiply by the 2 plus root 3, the conjugate will be 2 minus root 3. So in numerator and denominator, both we multiply by 2 minus root 3. So what will happen? We will get 2 minus root 3 in numerator, and in denominator, look at this carefully, we also have a rule that says a plus b into a minus b. It becomes a square minus b square. Now here you see 2 plus root 3 and 2 minus root 3. It is a plus b into a minus b. So it becomes a square, that is 2 square, minus root 3 square. Right? So it is 2 minus root 3 divided by 2 square is 4 minus root 3 square is 3. So it is 1. So 2 minus root 3 divided by 1. So what we have finally is 1 by 2 plus root 3. Right? When it is rationalized, it becomes 2 minus root 3. Right? This is the simple meaning of rationalization. Okay, let's take one more example. Suppose we say that rationalize 1 by 2 root 3 minus 5. Alright, now how do we go ahead with this? Simply multiply by the conjugate of this. Now this conjugate of this will be clearly 2 root 3 plus 5. So multiply by 2 root 3 plus 5 in numerator as well as in denominator. So this will become 2 root 3 plus 5 whole divided by, it is a minus b into a plus b. So it is a is 2 root 3, b is 5. So it becomes 2 root 3 square minus 5 square. Right? So this gives us 2 root 3 plus 5 divided by, 2 root 3 square will be, 2 square is 4, root 3 square is 3. So 4 3s are 12 minus 5 square is 25. So this becomes 2 root 3 plus 5 divided by minus 13. Nothing to worry, just the answer is minus 2 root 3 plus 5 divided by 13. Please understand that 1 by 2 root 3 minus 5, that is equal to minus of 2 root 3 plus 5 divided by 13. Right? This is the answer. So this is the rationalized form of this number. Alright. So this is the method of rationalization. Basically, you have to make sure that there is no irrational number in the denominator. Okay. Now let's take a couple of questions on this. Let's take the first question as simplify 13 upon 5 minus 2 root 3 minus 44 upon 7 plus 3 root 3. Right? Let's take this question. Now whenever we say simplify and there is an irrational number in denominator, please understand that it has to be rationalized properly. Now here there are two expressions. We have to separately rationalize them. Okay, so let's do it like this. We write the first one, that is 13 divided by 5 minus 2 root 3. Now conjugate of 5 minus 2 root 3, we only have to look at the denominator for rationalization. So here denominator is 5 minus 2 root 3. Conjugate will be 5 plus 2 root 3. So just multiply by 5 plus 2 root 3 in numerator as well as denominator. Right? Similarly in the second one, it is 44 divided by 7 plus 3 root 3. So what we have to do is, now 7 plus 3 root 3, the conjugate will be 7 minus 3 root 3. So just multiply by 7 minus 3 root 3 in denominator and numerator both. Now the first one becomes 13 multiplied by 5 plus 2 root 3, right? Don't open the bracket as of now. In denominator it will be 5 square minus 2 root 3 square, alright, minus. Here the second part, 44 into 7 minus 3 root 3 will be the numerator. Denominator will be 7 square minus 3 root 3 square, alright. Now let's see. Now this is 13 into 5 plus 2 root 3 whole divided by 5 square is 25, 2 square is 4 into 3, 12. So minus 12 minus, second one is 44 into 7 minus 3 root 3 divided by 7 square is 49 minus 3 root 3 square. So 3 square is 9, root 3 square is 3. So 9 into 3, that is 27. Alright. So what happens now is that we get 13 into 5 plus 2 root 3 divided by 25 minus 12, wow, it is 13. Okay, minus 44 into 7 minus 3 root 3 divided by 49 minus 27, great, it is 22. Now why? Because this 13 gets cancelled by this 13 and this 22 cancels 44 2 times. So what we have finally is that 5 plus 2 root 3 minus 2 times 7 minus 3 root 3. Right? Now open the bracket. So it will be 5 plus 2 root 3 minus 2 sevens is 14 minus minus plus 6 root 3. Alright. So the final answer will be 2 root 3 plus 6 root 3, that is 8 root 3, and plus 5 minus 14, that is minus 9. This is the final answer of the question. This is the final simplified form of the question that was asked. Alright. But primarily what we need to understand that whenever we have an irrational number in denominator, what we have to do is we have to simply rationalize each part of that number. Okay, that's what we did, and we get the final answer as 8 root 3 minus 9. Okay, now let's go ahead to the next question. Now the second question says x is given 3 plus 2 root 2, find 1 by x, then x minus 1 by x and x plus 1 by x, right? Let's do it one by one. We already have x equal to 3 plus 2 root 2. First, let's try to find 1 by x. Now, 1 by x will be 1 by 3 plus 2 root 2. Right? Now, we have to first rationalize this. Now, 3 plus 2 root 2, the conjugate will be 3 minus 2 root 2. So, just multiply by 3 minus 2 root 2 in numerator and denominator. We will have 3 minus 2 root 2 whole divide by 3 plus 2 root 2 into 3 minus 2 root 2. This is a plus b into a minus b. So, it becomes 3 square minus 2 root 2 square. Okay. So this becomes 3 minus 2 root 2 divided by 3 square is 9, 2 root 2 square. 2 square is 4, root 2 square is 2. 4 into 2 is 8. So it becomes 3 minus 2 root 2 divided by 1. So it is 1 by x is equal to 3 minus 2 root 2 divided by 1, which is 3 minus 2 root 2. Right? So our first question, that is 1 by x, that is equal to 3 minus 2 root 2. Okay. Now, let's take the second one, that is x minus 1 by x. How do we do it? We have to find x minus 1 by x and x plus 1 by x. Okay. So first I'll say that we have x equal to 3 plus 2 root 2 and we have 1 by x equal to 3 minus 2 root 2. Alright. And now from here we have to find x minus 1 by x and x plus 1 by x. Let's look at this. Now x minus 1 by x will be 3 plus 2 root 2 minus, in place of 1 by x, it will be 3 minus 2 root 2. Simply open the bracket, it will become 3 plus 2 root 2 minus 3 plus 2 root 2. So 3 and 3 are cancelled and 2 root 2 plus 2 root 2, it will be 4 root 2. So the final answer of this will be 4 root 2. And x plus 1 by x, let's see, it is 3 plus 2 root 2. In place of x, it is 3 plus 2 root 2. In place of 1 by x, it will be plus 3 minus 2 root 2. So if you open, it is 3 plus 2 root 2 plus 3 minus 2 root 2. So 2 root 2 this time gets cancelled, and we have 3 plus 3, that is equal to 6. So 1 by x is 3 minus 2 root 2. X minus 1 by x is 4 root 2, and x plus 1 by x is 6. So these are the answers of this question. Alright, let's take one more question. The next question, it says 1 by root 3 plus 1 plus 1 by root 5 plus root 3 plus 1 by root 7 plus root 5, and it goes on up to 1 by root 81 plus root 79, and we have to simplify this. Alright, we have to simplify this. Now how do we do this? You see that there are so many terms here, but we don't need to worry. What we need to do is we need to take the terms separately. This term once, and so on. Let's take the first one. It is 1 by root 3 plus 1. Let's rationalize this. So we have to multiply by root 3 minus 1 in numerator and in denominator. So this becomes root 3 minus 1 divided by root 3 plus 1 into root 3 minus 1 will become root 3 square minus 1 square. So this gives us root 3 minus 1 divided by 3 minus 1, which is 2. So it is root 3 minus 1 upon 2. That is 1 by 2 into root 3 minus 1. Similarly, the next one, that is 1 by root 5 plus root 3. If we have to rationalize it, we have to multiply by root 5 minus root 3 in numerator and denominator. From there, what will happen? We will get root 5 minus root 3 in numerator divided by, in denominator we will have root 5 square, that is 5, minus root 3 square, that is 3. So it is root 5 minus root 3 divided by 2, which is 1 by 2 into root 5 minus root 3. As you can see, this will continue like this. Okay, let me take one more here. Let's say 1 upon root 7 plus root 5. We have to multiply by root 7 minus root 5 in numerator and denominator, because that is the conjugate. So we will get root 7 minus root 5 divided by 7 minus 5. Now 7 minus 5 is 2. So it is root 7 minus root 5 divided by 2, which is half into root 7 minus root 5. This will continue like this. So even the last one, that is 1 by root 81 plus root 79. Okay, this can be multiplied. This has to be multiplied by root 81 minus root 79 in numerator as well as in denominator. Alright, so this will give us root 81 minus root 79 divided by 81 minus 79. That is root 81 minus root 79 divided by 2, which is half into root 81 minus root 79. Now look at this closely. If you add all of them, alright, on the left hand side you will get the question that was asked. On the right hand side, what will happen? Half will be common, right? Half, you can see half is there everywhere. Half is there everywhere. So half becomes common, okay, right? And this continues as a series. Now look at this closely. This root 3 here is positive and root 3 here is negative, so it gets cancelled. Similarly, root 5 here is positive, root 5 here is negative, gets cancelled. That means root 7 positive here will get cancelled from the next one, and it will continue like this. Here minus root 79 will get cancelled from the previous one. So what will be left in the end? In the end, we will have this root 81 from the last term and minus 1 from the first term. Alright. So our the expressions which was asked in the question will become, the expression that was asked in the question, it will become half into root 81 minus 1. Now it is half into, now what is root 81? Root 81 is 9. 9 minus 1 is 8. So it is half into 8. Now half into 8 is 4. So the answer of that question is 4. But the basis of this question was the process of rationalization. Alright. So this was one very important question and a good one, because it was based on the series. So I'll explain just once more. What we are saying here is, root 3 positive here becomes root 3 negative here and gets cancelled. Root 5 gets cancelled. Root 7, from the next one we will have minus root 7 here, and that will get cancelled. This here root 79 is getting cancelled from the previous one, and this entire series gets cancelled. Only from the first term the second part, and from the last term the first part, they get remained. they remain there, right? So root 81 from here and minus 1 from here. We take it in the final answer. All right. Now let's take up the next type of question, that is square root. Square root of an irrational number. All right. Now in this, there is nothing technical about it. It's a simple fixed process that we have to follow. Okay. And how do we go about it? Before that, I'll just recall the formula, that is a plus b whole square. We know it is a square plus b square plus 2ab. Right? Similarly, a minus b whole square, we know it is equal to a square plus b square minus 2ab. Now, in place of a and b, if I take root a plus root b, what will happen? If you square it, you will get root a square is a, root b square is b, plus 2 root ab. Right? Similarly, if I have root a minus root b whole square, what will happen? We will get a plus b minus 2 root ab. Right? We'll use this thing. Okay. How do we use this thing? I'll just show it to you. Let's take up a question. I think that will be useful. Let's say if the question says find square root of 31 plus 12 root 3. That means we have to find, what we have to do is we have to find square root of 31 plus 12 root 3. How do we start here? Let's assume that root of 31 plus 12 root 3 is equal to root a plus root b. Why? Please understand, this 31 plus 12 root 3, this is an irrational number because of presence of root 3. Right? So even the square root of this whole number will definitely be an irrational number. Now, which part will be rational or which part will be irrational? Let's not get into that discussion. Let's assume that both are irrational, root a plus root b. Right? Now what you should do, now square on both sides. So first you assume that given this thing is equal to root a plus root b, and also remember that if there is a plus sign here, take plus root a plus root b. If it was minus sign, if it was 31 minus 12 root 3, you should have taken root a minus root b. Here it is plus, so we have taken root a plus root b. Now square on both sides. What will happen? If you square on both sides, let me write it properly. Every statement, it will be root of 31 plus 12 root 3 whole square is equal to root of a plus root of b whole square. Now on the left hand side, we will have the square root will go away. So it is just 31 plus 12 root 3. And on the right hand side, we will have a plus b plus 2 root ab. Now this is a very important step now. See, a plus b is a rational number. 2 root ab is an irrational number on the right hand side. Similarly, on the left hand side, 31 is a rational number. 12 root 3 is an irrational number. So the numbers of the same species should be equated. So what do we get from here? We get a plus b equal to 31. That is one equation. And 2 root ab is equal to 12 root 3. Okay. Now if you divide by 2, 2 cancels 12 6 times. So we have root ab is equal to 6 root 3. Okay. Now again square. If you square again, what will happen? You will get ab equal to 6 root 3 square. Now 6 root 3 square will be 36 into 3, that is 108. So what we have now is a plus b equal to 31, right? And a into b is equal to 108. Now there are many ways of solving these two equations and finding the values of a and b. I would suggest that what you should do is just break this 108 into two parts. How can you do that? Let's see. 1 into 108, right? 2 into 54. So if you remember the basic tables, you can do it very fast. 3 into 36, 4 into 27, 5 will not be a factor, 6 into 18, 7 will not be a factor, 8 will not be a factor, 9 into 12. I think this is the last pair, right? Because after this it will be 12 into 9. So no need to repeat. Okay. Now, what you should do is we have already broken a 108 into two parts, a product of two numbers, and we get possible values of a and b. The condition is the a plus b should be 31. So let's do one thing. Add here. So 1 plus 108 is 109. Here we have 31, so it is wrong. This is not the correct possibility. 2 plus 54, it will be 56. Again wrong because we want 31. So basically find that possibility where after addition you get 31. So from there you can see that 3 plus 36 is 39. That is wrong. 4 plus 27 is 31. Right. This is the correct possibility. Right. So we have 108 equal to 4 into 27 as the correct possibility. Now the question comes, which one is A, which one is B? One thing is very clear. Always, by default, always take like this, that A is greater than B. Always, so that there is no confusion at all. So we'll take A equal to 27 and B equal to 4. Right? So remember the question. What was the question? Question was square root of 31 plus 12 root 3. Right? And this we had assumed to be root A plus root B. So our answer will be root A plus root B. Now root A will be root of 27 plus root B will be root of 4. Now root of 27 is 9 into 3. Right? Root of 27 can be taken as root of 9 into 3. So it becomes root 9 is 3. Root 3 will remain as it is. So it is 3 root 3 plus 2. So the answer of this question is 3 root 3 plus 2. Alright. So this was a really good question. Let's take one more. Let's say the second question, if I say find square root of 69 minus 28 root 5, right? Please pay attention. Let's assume that square root of 69 minus 28 root 5 is equal to root A plus root B. No, you cannot take plus. See, here it is minus sign. So in this case, instead of plus, you should take minus. So let me change it, right? Let's take it as root A minus root B, right? Now square on both sides. When you square, you will get root of 69 minus 28 root 5 whole square equal to root A minus root B whole square. Okay, so this will give us A plus B minus 2 root AB. And this side we have 69 minus 28 root 5 equal to A plus B minus 2 root AB. From there you can see that 69 is going to be equal to A plus B, minus will remain as it is, and 28 root 5 will be equal to 2 root AB, right? So I'll write A plus B equal to 69, okay, and 2 root AB is equal to 28 root 5. Now 2 cancels 28 14 times, so root AB is equal to 14 root 5. Now from here, if you square, you will get AB equal to square of 14 root 5. Alright. Now that is equal to AB equal to 14 square is 196. Root 5 square is 5. Okay. So it is AB equal to 196 into 5 is 980. Okay. So we have two equations again. A plus B is 69. A into B is 980. And we have to find the values of A and B. Alright. So let's do one thing. Let me write all the possibilities here for A into B equal to 980. Just keep in mind that their sum has to be 69, right? So even if you start from 1, it doesn't take much time. Let's see. 1 into 980, 2 into 490, 3 will not be a factor, 4 into 245, 5 into 196, 6 will not be a factor, 7 will be a factor, it will be 140, then 8 will not be a factor, 9 will not be a factor, 10 will be a factor, 10 into 98, 11, 12, 13 will not be a factor, 14 will be a factor, 14 into 70, 15 will not be a factor, 16, 17, 18, 19 will not be a factor, 20 will be a factor, that is 20 into 49. You know, just keep on adding also. This is more than 900, not possible, not possible. More than 300, more than 200, around 140. This is 98 plus 10, not more than 100. 14 plus 70 is 88, not 84, not possible. 20 plus 49, this is 69. See, understand, you have to keep this thing in back of your mind, right? So we get our values as 20 and 49. Now, so we have A into B as 49 into 20. As we said, the larger one has to be taken as A and the smaller one has to be taken as B. Now this means A is equal to 49, B is equal to 20. Now what was our question? Our question was square root of 69 minus 28 root 5, which we had assumed to be root A minus root B. So our answer will be root of 49
minus root of 20. Now root of 49 is 7. Root of 20 will be, see, 20 is 4 into 5. So root of 20 will be root of 4 into 5. Root of 4 is 2, so it is 2 root 5. Right? So 7 minus 2 root 5. Okay. So the final answer of this question is going to be 7 minus 2 root 5. Alright. So this is where we have completed, I think, a good quantity of questions, almost all types of questions related to surds.
Alright. Thank you so much. God bless you. Take care.